Good afternoon, students. Today we want to discuss about titration. So titration is a practical question that is set in paper 3. So there is a number of things that you need to know in titration. So number one, we normally have a table which you are required to fill that table, and those values in which you fill the table, we normally have some rules that will guide you for you to get full marks. So number one, in this table, we normally have a three-column table and a 3-rows table. We normally have the final burette reading, initial burette reading, and also the volume used. So the first thing in this table, you ensure that you fill this table complete for you to get 1 mark. That is the first rule. You just fill. You have a mark for that one. Number two, you ensure that the values that you are filling are consistent. Consistent means that these values are in the range of plus or minus 0.2. Plus or minus 0.2. That is what you call consistency. You ensure that the values are consistent. The volume of the solution used is consistent. Then number 3 is the number of decimal places. The number of decimal places should be 1 decimal place for you to earn a mark. So those 3 things ensure that you keep it at the back of your mind before you start answering a question in titration. Now, the first question that is asked in this titration, number 1, is to calculate the average volume of the solution used. We normally have the solution used. Because you normally do 3 experiments. You have the first experiment, second experiment, and the third experiment, and then they require you to calculate the average volume. That is the first question that will be asked in each and every practical exam. So the average volume of the solution used, you add this because considering the table, like for our case, we have we studied the final volume used, initial volume, and the volume used. So the volume used, you take the final minus initial. Final minus initial, you get the volume used. So in our case, we have done 3 experiments, so we want to find the average. So you add 12.4 plus 12.5 plus 12.6. Then you divide. So you have 3 experiments, you divide by the number of experiments. So when you add, then you divide that one, you will get this 12.50 centimeter cubic. Another thing that students should know is that these decimal places for the average volume, it should be in 2 decimal places. We normally say 4 significant figures. So if it is in 1 decimal place, that is wrong. It should be in 2 decimal places. So you can see I have added here a 0. Though this 0 is not significant, but it's a decimal point. So it is in 2 decimal places. That is the first thing that you also need to consider. So doing this, you have 4 full marks up to the average volume. Then there is also a question that is asked here. Like for example, question B, calculate the concentration of the dibasic acid solution B. The concentration. So what is concentration? Concentration just means moles per liter. You normally take the molarity, you divide by the volume, or you divide by the volume of the solution. So concentration is expressed in mole per liter. So first of all, you need to know the dibasic acid. That is now sulfuric 6 acid. Dibasic, di means 2. Dibasic acid, that is sulfuric 6 acid. So you need to know the moles of sulfuric 6 acid. In this case, you have been given what? The mass of the acid as 4.9. We have the mass as 4.9. Then you have been also been given the molar mass. So you need to calculate the molar mass of the sulfuric 6 acid. So when you calculate the molar mass, hydrogen, that is 2 plus sulfur, that is 12. Sorry, the marker pen is then some complications. Let us end it. Okay, so hydrogen you have 2 atoms, sulfur you have 12, the molar mass of sulfur. The molar mass of oxygen is 16, but here you have 4 atoms, so you multiply by 4, that is 16 times 4. So when you sum up all this, you get 98 mole, grams per mole. That is now the molar mass. Now I want to calculate the moles. The moles is what? Mass over molar mass. That is now grams per liter. So this is now will be 4.9. You divide by 98. So when you work out this one, you are going to get 0.05. 0.05 moles. Now, in our experiment here, we have been given some procedure. These procedures are the one that will be guiding you. So you have been given this procedure number 2, that the solution B containing 4.9 grams of dibasic acid, sulfuric acid, in a 500 gram centimeter cubic of solution. So it means that the number of moles that are in this solution of sulfuric acid is 0.05. And as we know very well that concentration or molarity per liter means 1000 centimeter cubic. So it means that this 0.05 moles are in 500 centimeter cubic. What about 1000 centimeter cubic? Keeping in mind that concentration is mole per liter. Liter it consists of 1000 centimeter cubic, and that's why we are saying that what about 1000. So when you work out this one, you decide that this is now 1000. We are multiplying this one by 0.05, then you divide this one by 500. We are going to get 0.1 m, or can talk of m per liter. That is now the concentration. When you leave it at m, that is molarity, but you need to put m per liter. That is now the concentration. Then another question that may be asked. So when you work out this one, all of this one is 2 marks, or some teachers or some examiners may award you 3 marks, but it is usually 2 marks. Then you also have another question, that is C. Write a chemical equation for the reaction between a dibasic acid, solution B, and sodium hydroxide. That's a reaction between a base and an acid, and that's what we call neutralization reaction. Neutralization reaction. So this reaction, it results to a product and 2 products. That is now salt and water. And salt results from the from the acid. So when you write the equation here, that is sulfuric 6 acid, that is H2SO4 plus sodium hydroxide. That's a chemical equation. You will get that is sodium sulfate. I said that the acid comes from the salt comes from the acid. So that is sodium sulfate. Remember very well that sodium is valent 1, so, and sulfate is valent 2, so you add that 2, then plus water. Then you balance the equation. Let's see if ours has been balanced. So I'm going to put here 2, then I put here 2. So we have 4 atoms of hydrogen, the reactant side 4 atoms of hydrogen, 1 atom of sulfur, 1 atom of sulfur, 5 oxygen, 6 oxygen, 6 oxygen, 2 sodium, 2 sodium. The equation is balanced. That is only 1 mark. 1 mark, or some example will give you a half a mark, because that one is not a very big issue there. Then we have question D. Calculate the number of moles of the dibasic acid, solution B, in the average titer volume. In the average titer volume. The number of moles in the average titer volume. So we have calculated the number of moles of sodium hydroxide. So the solution A is now the acid. That is now what we have found, the average titer. So in our case here, we have the molarity, the molarity, that is we have what? We have the volume, the average titer, that is now the volume of the acid. The average titer as 12.5 centimeter cubic. Keeping in mind that we have gotten the concentration of diabatic acid, we can also calculate the number of moles of the diabatic acid. There you have been given the number of moles. So here the number of calculate the number of moles of the diabatic acid solution B in the average titer. So the average titer here is so we have seen that in 500 centimeter cubic you have 0.05. So you can use 12.5 centimeter cubic. We see how many moles will we get here, because in 500 the number of moles was 0.05. Now what about 12.5? So here it will be 12.5 . So here it will be 12.5 times 0.05, then you divide this one by 500. So here we will get our moles. Let me look for the calculator. Acid, that is now the acid of the number of moles in the number of moles of the diabatic acid solution B in the average titer volume in 12.5 centimeter cubic. Then another question, the number of moles of solution C that reacted with the solution B in the experiment. So solution C is sodium hydroxide. So already we have calculated the number of moles of the acid here. So here we just use the mole ratio. So here it is 1:2. So you just say if the number of moles of the acid, if the mole ratio is 1:2, acid is 1, then sodium hydroxide is 2. It means that we are going to multiply the number of moles of acid times 2 to get the number of moles of the sodium hydroxide, because when you look at our equation, the mole ratio is 1:2. So after finding the number of moles of the acid, we will go and multiply with 2 to get the number of moles of sodium hydroxide. So this is what we call an equation. This one is guided by our equation there, a stoichiometric equation for that case. Then we have the number. Calculate the molarity of solution C. So after getting the number of moles, we are going to say that molarity is expressed in 1000. So you are going to say that molarity is just the same as concentration times number of moles, or you can just say volume in liters times the number of moles. So the volume in liters times the number of moles. But for this case, we are just going to say, because we have been used a pipette, we have sucked 25 centimeter cubic of the solution. So after getting the number of moles of sodium hydroxide, we are going to say if 25 centimeter cubic, that is what we have sucked from the pipette. We are going to say if in 25 centimeter cubic we have the number of moles of sodium hydroxide solutions, moles of C. Now what about 1000 centimeter cubic? You should keep in mind that molarity is in mole per liter. So what about 1000? So when you find the number of moles of sodium hydroxide, you are going to equate with the 25 centimeter cubic and 1000. Then you get the number of moles, the molarity of solution C. So that is now our first table in titration. I'm coming up with another table so as I can elaborate where some of you have not understood, for you to understood more. And continue subscribing to our channel, and may God bless. In quite some time I'll be back here with another table. Thank you. Welcome back to another titration table, another question 2. Now for this case, you have also been given sodium, but this one is a back titration question. Back titration, because you have been given a carbonate and an oxalic acid, and also sodium hydroxide, a carbonate, an acid, and a base, 3 reagents, and also an indicator. And here we are going to determine the enthalpy change for the oxalic acid of the oxalic acid. Now, for the filling the table, the procedure or the rules are the same. First of all, you ensure that you fill the table. Ensure that the table is filled full. You'll get a mark for completing the table. Then number 2, ensure that the values are in 1 decimal places, or you can talk of 3 significant figure, but it is only 1 decimal places. Then number 3, ensure that the consistency, it is in the range of plus or minus 0.2. Now here we have the procedure. You have been provided with 0.12 molar sodium carbonate. So this is now the reagent that you have been given 0.12 molar sodium carbonate. That is now solution A. So in solution A, then you have been also provided with oxalic acid. That's a weak acid. This one is a weak acid with the 2 moles of water. That is one is solution B. I have also been given sodium hydroxide, which is also solution C, and also methyl orange indicator. Then you are required to standardize solution B, and I think all of you know the meaning of standardization. Then you determine the enthalpy of neutralization of oxalic acid. Now this is the table. I have done my experiment thrice, and I have got these values. The first one, initial one, the burette was reading 0.00, then the final volume was 20.0. I also filled the burette up to 0.00, then I also titrated up to 20.0, then I also refilled the burette up to 0, then and I titrated to 20.0. Then I came here and find the volume used by taking the final volume minus initial volume. Now, the first question is obvious. Calculate the average volume of solution A used. Calculate the average volume of solution A used. So that is a simple question that none of you should fail. You add all of them, then you divide by the number of experiments that you have done. If it is 4, you divide by 4. If it is 3, you divide by 3. If it is only 2 experiments, you divide by 2. So you will get 20.00 centimeter. You ensure that it is in 2 decimal places. That is a key point. Ensure that the average volume is in 2 decimal places. Then number 2, determine the number of moles of solution A used. The number of moles of solution A used. You have been, solution A is sodium carbonate. Sodium carbonate is the one that we are using to standardize this acid, oxalic acid. So you have been given the molarity as 0.1. That is the molarity of 0.12. The molarity of solution solution B, that is the auxiliary solution A, that is the sodium carbonate. So you have been given the molarity. Now, so we have been asked to calculate the number of moles. So we are going to say if 0.12 molar is equivalent to 1000 centimeter cubic, because molarity is expressed in 1000, it's always in 1000 because it's a mole per liter, so it is in 1000 centimeter cubic. What about now the average volume that you have got here? That is 20.0. So I'm going to take 20.0 divided by 1000, then you multiply by 0.12, which will get what? 0.0024 moles. You're going to get 0.0024 moles. That is now the number of moles of the solution A used. That's only 1 mark. Then we also have another question. Calculate the number of moles of solution B used given that 2 moles of oxalic acid reacts with 3 moles of sodium carbonate. That is a very simple question. We are saying that calculate the number of moles of solution D. Solution D is what? Solution D is solution D is the acid when you have added some water, distilled water, then you label that solution D. So we are going to say the number of moles of solution A was 0.0024. Sorry for rubbing 0.0024 because we are going to use in this calculation moles. So we are saying that if solution D used given that 2 moles of oxalic acid react with 3 moles of sodium carbonate. So it means that 2 moles of oxalic acid is in react with 3 moles of sodium carbonate, and keeping in mind that we have calculated the number of moles of sodium carbonate. So it means that these 3 moles is equivalent to 0.0024 moles of what? Of sodium carbonate. What about now 2? So it is 2 over 3 multiplied by 0.0024. So we are going to get 0.0016 moles of solution D. Because solution D, we have just added water in sodium carbonate. You have just added water in an oxalic acid. You have just added distilled water in an oxalic acid. Then you have labeled that solution D, and you have been given the number of moles. So it's just a matter of comparing. Then you have question D here. Determine the number of oxalic acid solution D in 250 centimeter cubic solution. So remember that you have sucked using our pipette 25 centimeter cubic solution D. So it means that 0.0016 moles is equivalent to 25 centimeter cubic. But you have been asked to calculate the number of moles of solution B in 250 centimeter cubic. So this one is in 25 centimeter cubic because of the solution that you have sucked by using our pipette. So what about 250? So you're going to take 250 divided by 25, then you multiply by 0.16 moles. And this one you're going to get our answer as what? Sorry for that case. There's some mess somewhere. Sorry. We are saying that determine the number. Yeah, it is true. We are just correct. 0.0024 0.016 equivalent 25 centimeter cubic. What about 250? So it is 250 divided by 25, then you multiply by 0.0016 moles. So on this one you are going to get as also 0.0160 moles of solution B in 250 centimeter cubic. Then we have another question here. The number of moles, calculate the number of moles of oxalic acid solution B in 25 centimeter cubic solution. So they want the number of moles of oxalic acid solution B in 25 centimeter cubic solution. So for this case, so calculate the number of moles of oxalic acid solution B in 25 centimeter cubic solution. So in 25 centimeter cubic solution, we are going to say that you have been given 250 centimeter cubic. So you have calculated the number of moles in 250 centimeter cubic. So in 250 centimeter cubic, that is now solution B. And remember, we know the number of moles of oxalic acid. The number of moles of oxalic acid in the average titer. Let me see, oxalic acid, that is solution B. The number of moles, 2 moles of oxalic acid reacts with 3 moles of sodium carbonate. So here we need to calculate the number of moles of oxalic acid in the average titer first by using our equation. When this sodium carbonate reacts with an oxalic acid, what are the product here? Then we compare, because we already know the number of moles. So here we need to write a stoichiometric equation. We have sodium carbonate plus H2, that's oxalic acid, C2. Then you have 2 moles of water. Then you are going to get sodium bicarbonate, that is now the salt, plus water plus carbon 4 oxide, sodium bicarbonate plus water plus carbon 4 oxide. Let us now balance our equation here. So we have sodium 2 moles, 2 atoms, carbon, we have 3 oxygen, have 3 plus 2, that is 5, 3 plus 2, that is 5, hydrogen, we have 4, 2 plus 2, that is 4, that is now 8, here we have 4, we have 2, so we are going to put here what? 4, and I think our equation will be balanced. Hydrogen, that is 4, here is 4 plus, then here we are going to put here 3, not 4, so 3. Our equation is balanced. Now here they are testing you on how to write an equation when sodium carbonate reacts with the oxalic acid, and I know most of you here could have failed because you don't know the salt that will be formed. The salt that is formed from sodium carbonate and oxalic acid is sodium bicarbonate. and this is how they write the formula for sodium bicarbonate with water plus carbon oxide. And you have seen the equation is correct and it's balanced. Now when you write this equation, that's now where we're going to get this question, this mark correct, because now the mole ratio is now 1:1. The mole ratio is 1:1. So it means that the moles of the oxalic acid, here, we have calculated the moles of sodium carbonate as 0. What? The moles of sodium carbonate was 0.0024 moles. That one is the moles of sodium carbonate. So it means that the moles of sulfuric acid is also this one, because the mole rate is 1:1. Are we together? Not sulfuric but oxalic acid is also this one. So this one now are in the average titer, and the average titer is 20.0 centimeter cubic, but they want you to calculate it 25 centimeter cubic. So we are going to say, if this one are in 20.0 centimeter cubic, what about now 25 centimeter cubic? It's now 25 divided by 20. We are multiplying this one by 0.0024. So when you calculate this one, you will get the number of moles of the oxalic acid in solution B of 25 centimeter cubic. So you will calculate and get your answer here as the number of moles. Then the last question, the concentration of the oxalic acid in solution B in moles per liter. So the concentration, we are just going to say, if the number of moles that you have gotten here is equivalent to 25, what about 1,000? Then you get your concentration. Then you must put there mole per liter. Don't just say M. M is molarity, but concentration, we never read the concentration is the same as molarity, but for the units, concentration must be moles per liter. So continue doing some more examples, and I will be giving more tutorials and tips on how to calculate and these sample questions, because titration never means in case you see. That is a hot cake. When you are good in titration, in paper 3, you are just okay. Thank you for watching and continue subscribing. My name is Okanga Jacob. Mr. Gideon will come with another topic, and that is Gay-Lussac's law. Thank you for watching.